So let's get right into it. Have you ever just stopped and thought about how we're actually going to build a future in space? Get to Mars, set up bases on the moon, especially when just getting off our own planet is one of the hardest and most expensive things we do. Well, the answer might not be about launching more from Earth, but about using what's already out there, just waiting for us. Okay, to really get it, think about what we call the packed car problem. Imagine you're about to drive across a massive desert, but you have to pack everything, and I mean everything from the very start. All your food, all your water, and most importantly, every single drop of gas for the entire trip. Your car would be ridiculously heavy, right? Well, that's a rocket launch. The sheer weight of all the stuff we have to carry, especially the fuel needed to escape Earth's gravity, just makes the costs skyrocket. It's the biggest thing holding us back. But what if you didn't have to pack all that fuel? What if you could find a gas station along the way? What if you could just live off the land? That right there is where the whole game changes. And this idea of living off the land has a proper name. It's called ISRU, which stands for In-Situ Resource Utilization. It's a fancy term for a really simple, powerful idea. Use what's already there. Instead of dragging every kilogram of water, oxygen, and building material out of Earth's deep gravity trap, we harvest and process it right where we need it, on the moon, on Mars, or, like we're focusing on today, from asteroids. So if you're going to go prospecting in the solar system, what's the most valuable resource you could possibly find? Is it gold, platinum? Nope. Turns out it's something way more common, but 1,000,000 times more useful. It's water. Water is the oil of the solar system. Seriously. That one simple molecule, H2O, is literally the key that unlocks the entire high frontier. And what's so cool is how it works. You take a water-rich asteroid, what they call a C-type asteroid, and you just cook it. You apply heat and it releases water vapor. You capture that, condense it, and boom, you have liquid water. And from there, you're off to the races. You've got drinking water, you've got breathable air, you can even use it for radiation shielding. But the real prize, the absolute game changer, is when you use a little electricity to split that water into pure hydrogen and oxygen, because that is the most powerful chemical rocket propellant we have. And this is the payoff. This is what it all leads to. Once you can make propellant in space, you can build gas stations in orbit. Think about it. A rocket taking off from Earth is about 90% fuel by mass. That's insane. Imagine launching with just enough fuel to get to orbit and then filling up the tank for the long haul to Mars. It completely shatters the brutal math of the rocket equation that keeps us tethered to Earth. All right, so we know we can get this stuff and we know what we can do with it, but how do you make money from this? What's the actual business model look like? Well, it really boils down to two main strategies. Path 1, which is honestly the much smarter play, is to keep the resources in space. There's this concept called optical mining, where you could use giant mirrors to focus sunlight, kind of like a giant magnifying glass, and bake the water right out of an asteroid. A single, pretty modest mission could pull out maybe 100 metric tons of water. You'd create the value and use it right there in space, building the fuel depots and infrastructure for a real space economy. Then there's Path 2. This is the high-stakes, Hollywood-style treasure hunt, bringing it all the way home. Now, this is way, way harder, and it really only makes sense for super valuable stuff like platinum. We've actually already proven the basic concept with missions like OSIRIS-REx that brought samples back. The future version of this might involve processing the metal out in space and then sending it back in these sleek, glider-like shapes, basically creating our own artificial meteorites packed with treasure. I love this. It's like a menu for a space prospector. You can see right here, if you're looking for water to make fuel, C-type asteroids are your go-to, perfect for use in space, but totally not worth bringing back to Earth. Need iron and nickel for construction? You're looking for M and S types. And then for that big score, those platinum group metals, well, you're hunting for those really rare M types. That's the only thing that justifies the crazy expensive price of a return ticket. So how do you even move these massive chunks of rock or tons of water around? It's not like you have trucks up there. Well, you've got options. For the slow and steady trips, you use these super efficient solar electric ion thrusters. If you need to get somewhere faster, you can just burn some of that rocket fuel you literally just made from the asteroid itself. And for the final approach to Earth, you use aerobraking, letting our own atmosphere act like a giant free brake pad to slow you down. It's all about working smart. Now, I know what you might be thinking. This all sounds a little out there, like something from a movie decades away. But I want to be really clear about this. This isn't science fiction anymore. The foundational work, the stuff that makes all this possible, is happening right now.
Of course, let's be real, it's not easy. There are some serious challenges. In microgravity, when you try to drill into a rock, you might just spin your robot around instead. Processing ore takes huge amounts of power. And yeah, there are still a lot of legal and economic questions to figure out. But here's the thing, these are engineering problems, not physics problems. We've solved ridiculously tough problems to mine here on Earth, and we can solve these too.
And hey, if you need proof that things are moving, here it is. NASA's OSIRIS-REx mission just brought back a chunk of an asteroid. We're learning how to actually do this stuff. You've got private companies like Astroforge that are already testing how to refine metals in orbit. And major studies from top institutes have already confirmed that capturing and mining a small asteroid is totally feasible with the tech we have today. The ball is already rolling. So, what's the big takeaway here? ISRU completely changes our relationship with space. It turns spaceflight from a series of incredibly expensive one-way trips from Earth into a sustainable, self-supporting cycle. We go out, we harvest, we build, we refuel, and we go even further out. This vision of the future isn't a fantasy. It's the logical next step. It means the question is no longer if we'll build a real space-based economy. The question is, who's going to be the first to strike water and build that future?